Hey everybody, I want to show you how to find the equations of lines given a couple of different circumstances. One of these, well, these are things that actually come up in applications a lot. So although the examples we're going to do are kind of trivial, the idea of doing this actually is a real world application that is actually used quite a bit. So let's go do that. So what I want to show you is how to find the equation of lines, the equations of a line if you have, well, there's three different circumstances. One, if you have a point and a slope. Two, if you have 2 points. And three, if you have parallel or perpendicular lines. That one's going to take a little bit of explaining, but not too much explaining. So the thing that I really want to emphasize more than anything else is the thing that you need, or the information that you need in order to define a line, is a point and a slope. And that's it. That's all you need, point and a slope. Every time you are trying to find the equation of a line, that's what you're looking for, a point and a slope. And then you're going to use point slope form, which, if you recall, is this. Y minus y1 equals m times x minus x1, where x1, y1, oops, that's a 1, not an x. x1, comma, y1 is the point. Remember I said you need a point and a slope. That's the point, and m is the slope. So the first circumstance that we're going to do is if you have a point and a slope. We're just going to practice using point slope form. So if I want to find the equation of the line that has that goes through the point, let's say -1, 5, and has slope 2. Right? So let's say I'm looking for the equation of the line that goes through -1, 5 and has a slope of 2. All right, well, you could graph that if we wanted to. That's not what I'm going to do right now, though. I'm just going to plug in everything into the formula, right? So x1 is -1, y1 is 5, and m is 2, and I'm just going to jam it all into the formula. And remember, x and y are the variables, and x1 and y1 are numbers. They're the coordinates of the point. So I have y minus y1, which is 5, equals m, which is 2, times x minus x1. So x is x. x1 is -1, so I got minus a -1 here, so of course that's going to be a plus. So we're going to have y minus 5 is 2 times x plus 1. And technically, since I didn't specifically say we want to put it into slope-intercept form, we can totally stop there. Now, if we wanted to put it into slope-intercept form, which is a common request, we're going to want to distribute the 2 like this, and then move the 5 over. So let's go ahead and do that. So I have y minus 5 equals 2x plus 2. Add 5 to both sides. We get y equals 2x plus 7. And then we can graph that if we wanted to, but we just did that in the last video. I will go ahead and leave you to graph this on your own if you'd like. But that's the basic idea. Once you find the point and the slope that you are going to use, find the point that you're going through and the slope of your line, then you're home free. That's all you need because you just use point slope form and that's it. So let's do a slightly harder circumstance. Let's say I have 2 points. Let's say I have find the line through the points and these points. Let's say 1, 3, and what do I want to do here? Like maybe 5, -7. So I want the line that goes through those 2 points, 1, 3, and 5, -7. I'll go ahead and graph that. And interestingly, it's actually easier to graph this line than it is to find the equation of it. So 1, 3, 1, 2, 5, 6, 7, 8. That's not the greatest hash marks I've ever done. 5, 6, 7. We got 1, 2, 3. All right. So 1, 3 is like here-ish. And then 5, -7, 2, 4, 5, and then 2, 4, 6, 7. Okay, so that one there-ish, something like that. All right, so we have a line that goes through there, right? So that's the line we're looking for. Now, I don't know what the equation of that line is, right? And it doesn't look like it necessarily has nice intercept or slope or anything like that. So what we're going to do is we're going to figure out how to find it. Now, to do that, what we need to do is figure out any point on the line, of which we already have two, right? Either one of these will work fine as our point on the line. So we're all set on points. The thing we need is a slope, right? And so we can figure out the slope from the points, right? So I have this point 1, 3 and 0.5, -7. You can't see when I point, can you? I have this point 1, 3 and this point 5, -7. And so I can use those two things to find my slope, right? I've got my rise and my run, and I just need to find those things, right? So my run is the change in the x's. It goes from x equals 1 over to x equals 5. So that change is 4. And my rise is negative because it's going down, and it goes from 3 down to -7. So that distance is 10, right? So 3 to 0 is 3, and 0 to -7 is 7. So that's, yeah, those have to get 10. So I'll say -10 here. All right, so my rise equals -10, and my run equals 4. Okay, so my slope would be rise over run, -10 over 4, which if I reduce that is -5 over 2, just about a 2 out of both of them. And by the way, I'm doing something here that it might be a little bit subtle, but is 100% fine to do. I said the rise was -10, then I put my -10 in my numerator, and I left the negative in the numerator with the 10. And then when I simplified it, I pulled it out front. And you might ask yourself, is that okay? The answer is yes. A negative in the top or a negative in the bottom or a negative out front all mean exactly the same thing. So I prefer to put it out front just because it looks nicer. But if you left it as -5 over 2, that would be 100% correct as well. All right, that's it. Let's find the equation of the line here. So I've got my slope. I have my points. I can choose either one. And in fact, I'll go ahead and do both just to show you that they both give you the same equation, even though it seems like they wouldn't, right? If you have this equation, it really looks like using a different point, right? Different numbers for x1 and y1 should give you two different equations. It turns out they don't, which is kind of weird. But it does work fine. I'll go ahead and show you both of them. Do I want to do them both on the next page? I'll do the first one. So we're going to have y minus y1. So my first one, I'm going to use x1 is 1, y1 is 3. So I'm going to do y minus 3 equals m, -5/2, times x minus 1. All right, I'll just go through this. Y minus 3, distribute the -5/2. We got -5/2 x plus 5 over 2. Then we add 3 to both sides. Now 3, let's go off to the side here. 3 is, I'm going to need to add it over here, so I need to get a common denominator. So my common denominator is going to be 2. So the question is, what over 2 would give me 3? I'm thinking about it that way. I hope it's clear that it's a 6, right? So I'm going to add 3 to both sides. I'm going to add 3 on the left here, but I'm going to add 6 over 2 on the right, right? Those are the same thing, so that's okay. So y equals -5 over 2 x plus 11 over 2, and I got kind of squished up there, but that's my equation. -5/2 x plus 11 over 2. Now I'm going to go ahead and do that again with this other point, just to prove the point that it actually gives you the same thing again, even though it seems like it wouldn't, but it does. So it's going to be x1 is 5 and y1 is -7. So let's go ahead and do that. So we'll have y minus a -7 equals m, which is -5/2, times x minus x1, so x minus 5. I'm doubting myself that I remember the things correctly. 5 - 7. All right, I did that correctly. Good. So we're going to have y plus 7 equals, I'll distribute the -5/2, so we'll have -5 over 2 x plus 25 over 2, because 5 is 5 over 1. 25 over 2, negatives cancel. Then I'm going to subtract 7, and we're going to do the same thing we did before. Right, I need to subtract 7, so 7, and I need a common denominator of 2, but 7 is 14 over 2. So I'm going to subtract 7 here and subtract 14 over 2 over there. Those are the same thing. So we'll have y is negative 5 over 2x. And then 25 minus 14 is 11. So plus 11 over 2. And if we go back and look over here, hey, that's the same thing. And interestingly enough, if you use this formula, use the point slope formula, with any point on the line, it'll give you the same equation, which is pretty neat. It's a very non-intuitive result, I would say. So that's the equation of the line, negative 5 halves x plus 11 halves. And you can see negative 5 halves is a slope a little bit less than negative 2, right? It's negative 2.5. And this is pretty steep downward. And then the y-intercept is 11 over 2, which is 5.5. And if you look on here, that's plausible, right? It's above 3 at least. So I would buy 11 over 2 as the right thing. So that's the basic idea. We are going to use the points to find the slope by figuring out the rise and the run, right? So my rise here was negative 10 and my run was 4. And so that told me what the slope was. And then I used point slope form with a point and a slope to figure out, or with either one of these points and the slope I just found, to figure out what the equation of the line was. And that's the technique you're always looking for. Let me go back to the first thing I said. The thing you need, the things you need, the information you need is a point and a slope. And you jam it into this formula. That's how you do these. Okay, so there's actually a formula for the slope of a line between 2 points. That is basically just a formalization of the thing I just did a second ago, right? So let's say I have these 2 points. Let's add this. Let's get this going here. 1, 2, 3, 4, 5, 6. All right. So let's say I have the point 2, 1 and 4, 5. 2, 4, 5. So 4, 5. All right. So there's 2, 1 and 4, 5. Whoa, whoa, whoa! Oh no, things are going wrong. Okay. I moved my screen. 4, 5. And I wanted to figure out what the slope is of the line that's between that's at 6, isn't it? That is at 6. Gosh darn it. Hang on. I wanted it to be 4, 5, but I actually graphed 4, 6. One more try. 4, 2, 4, 5. Yeah. Okay. More like here. That's better. 4, 5. And I want to know what the slope of this line is that goes between them, or that would go between them if I could draw. And so we need to find the rise and the run. We need to find the change in x and the change in y, or change in y and change in x, right? So I'm basically making this right triangle every time, where this guy is the run, and this guy is the rise. And we're going to do slope is rise over run. And if you just stop and think about it for a second, it's pretty obvious what the rise and run are. The way you figure it out is how far is it from, or how far is it vertically from here to here, right? How long is that little line segment? And the way you can figure that out is it's the difference in the y coordinates, right? The height of this point is 1, and the height of this point is 5. So the change in height, or the rise, was 4 because it went up 4. And then similarly for the x coordinates, right? You want to know what the run is. It went from 2 to 4, right? Here's the x coordinate here is 4, the x coordinate here is 2. So the run is clearly 2. So the way we're finding those is we're subtracting. We're taking 5 minus 1 to get 4, and 4 minus 2 to get 2. So the rise is really, I'm going to call these points x1, y1, and x2, y2. x1, y1, just like we do in the point slope formula. And this is going to be x2, y2. And by the way, if you're not familiar with these little numbers that I'm using after the letters, those are called subscripts. And the idea behind them is I want this to be X and Y, but I also want this to be X and Y, and I can't just call them both X, right? Because they're different numbers. I can't have them both be called X. So what we do is we label them something with an X in it, right? So that they're both X's, but then we give them we number them so that we can tell them apart, essentially. That's really what this is. So the way we calculated the rise was we subtracted the Y coordinates. We did 5 minus 1 to get 4. So if I'm calling these x1, y1, and x2, y2, what I really did was y2 minus y1 for my rise, and x2 minus x1 for my rise. And that is what's called the slope formula. And this works if they are positive, negative, fractions, whatever. Like you just use this formula to find the slope, which you can go ahead and please go ahead and use the formula, remember the formula. But what I really want you to do is understand why it's this, so that if you ever forget the formula, you can just recreate it, right? Like I don't remember formulas necessarily all that well, and I end up having to recreate them a lot because I know what they're supposed to do. And so a lot of people think I have this incredible memory for formulas in math, and I don't actually. I end up having to recreate stuff a lot. And that ability is really, really helpful because it helps me make formulas before I even know what the formula is, because I know what I'm trying to do. And so I would encourage you to think of it that way, right? Think of slope not as y2 minus y1 over x2 minus x1, although it is. Think of slope as rise over run, and you're just finding how far apart 2 points are in the horizontal and vertical direction, right? That's really what you're doing. And so if you forget the formula, that's okay. You can just remember that all you're really doing is finding rise and run. And if you just graph the points, you can literally just count, right? I don't need to do any fancy calculations to find this. I can just count and say, oh, this is 1, 2, 3, 4, and then this is 1, 2. All right, so I guess my rise is 4 and my run is 2. Great. I forgot the formula, but it doesn't matter because I can just look and figure it out. All right, so anyway, this is called slope formula. You should remember this formula. If you don't remember the formula, you should absolutely remember what you are trying to find, which is rise over run. That's the goal of this. And this is just the formal version of that. Okay, so we actually used this a second ago, right? When we figured out when we figured out the -5 halves of the slope. That's how we figured it out, right? We did -10, we figured out the rise, and the run was 4, and then we just made a fraction and reduced it. Okay, so the other situation where you might find yourself in that you need to where you need to find the equation of a line is if you are given a point and then another line that you're parallel or perpendicular to. That's the other really common one. So let's see what those look like. The first thing we need to do is define what we mean by parallel and perpendicular, right? I know you know what parallel and perpendicular mean, but we have to define that in terms of what we know about lines. So if you don't know what parallel and perpendicular mean, here you go. So there is a set of axes. So these two lines are parallel because they go the same direction. Right? That's what parallel means. Parallel, same direction. A little sloppy with the handwriting there, sorry. So for us, the way we defined direction for lines is slope. A line's direction is its slope. So that really means same slope. And that's the way we want to do it. So if we know the slope of a line, all the lines that are parallel to that are lines with the same slope. Perpendicular lines are ones that meet at a right angle. Now that is not a useful definition for us. Actually, you know what I want to do? I want to erase those because I want to do something else. I want to do this. I want to make this line really steep on purpose. And then this perpendicular one is going to be, well, perpendicular to it. And I'll talk about why that's important in a second. So that's a right angle there. Perpendicular meets at a right angle. And so I'm going to use this idea to, I mean, I'll tell you what the formula is in terms of slope in just a second, but I just wanted to point out a couple things about this so that hopefully the formula makes sense to you. Notice that if this is going up as we go to the right, this is necessarily going down. So if this slope is positive, this one has to be negative. And I encourage you to check that out yourself, right? Like draw a line and say, okay, well, what if, what if I change this a little bit? Is that necessarily true? I assure you that it is, but investigate it yourself. And like if this one, if you have a negative, if you have a line that has a negative slope, the perpendicular line will have a positive slope. So two lines are perpendicular, or two lines that are perpendicular have opposite signs on their slope. If one's positive, the other one's negative. And if this line is very steep, its perpendicular line is very shallow, right? You can actually see that. Here, let's go over to Desmos. Do I still have that open? I think I do. Yeah, I still do. That one, please. Let's get rid of all these guys. So if I have a line that looks like this, equals plus b, a perpendicular line has the opposite slope, and you can see these guys are perpendicular, but if I changed m to something else, they wouldn't be anymore, right? Those are not perpendicular anymore. But if one is really steep, the other one needs to be really shallow. And the way we do that is like this. So you might notice here, I'm going to make this red. With my red and blue lines here, that as long as I change the sign and flip it over, take the reciprocal of the slope of one line, it gives me a perpendicular line. So here I can move b down to 0, so it's or down closer to 0. Notice that however I adjust this, those are always right angles. Right? There's always a right angle between them. And so that's the relationship. When one of them is really big, like my blue line has a slope of 2.3, the perpendicular one has a small slope of 1 over 2.3. It's just the reciprocal, right? You just flip over your fraction, 1 over whatever it was, whatever the original one was. So yeah, so that's how you get a perpendicular slope. The relationship is the sign is changed, so you change the sign, and you take the reciprocal. All right, let's go back to the whiteboard. Angle. So slopes are opposite reciprocals is the term. Opposite means to change the sign, and reciprocal means if the fraction turned over, just do 1 over whatever the other one is, which is actually the same thing. Oh, my handwriting. Sorry, it's I never had very good handwriting, and it's deserting me here. So that's what the relationship of the slopes are for parallel and perpendicular lines. Parallel is really easy. It's just the same. Perpendicular, you have to remember that it's opposite reciprocal, and again, that's just something to memorize. So let's say I have this. I want to find the line through 0, 4. No, that's too easy. I don't want to make that too easy. 1, 4. That's less easy. That is parallel to 3x minus y equals 7. All right, so I need to figure out what the line is, the line that I'm looking for. Now, here's where people get tripped up on these. Let's go back to the very beginning. The thing is I am looking for a point on the line, the slope of the line, that's it. I find those things, plug them into the point slope form, and then we're good. Here is the point I want, 1, 4. I need to find the slope of the line I am looking for. Well, this line is not the line I'm looking for. This line is a line that is parallel to the one I'm looking for, but it's not the line I want. So what I need to do is figure out what the slope of this line is, and then use that, right? Because parallel means the same slope. So parallel, same slope. So if I have a line that I know is parallel to the line I want, then I can use the slope of that line because it's the same as the one I want. So I need to find the slope of this line. Now, the easiest way to do that, in my opinion, is to just put it in slope-intercept form. I think that's the simplest thing we can do because then you just read it off. So let's do that. So I'm going to find the slope of 3x minus y equals 7 by putting it in slope-intercept form. I will subtract 3x from both sides, and I will end up with minus y equals minus 3x plus 7. And then multiply both sides by -1 to cancel out the negatives, and we get y equals 3x minus 7. Now, the slope of this line is 3, and the y-intercept is -7. And a lot of people think that that second thing matters, and it does not. The only thing I cared about, the only thing I was using this line for, was its slope, because it's parallel to the line I want, so it has the same slope as the line I want, which is 3, right? That's the only number I care about. I do not care about this in any way. Don't let this 7 trip you up. We're not using it. I'm just using the 3, and then I'm using this point. So I got my point slope form back from the very beginning, which I will remind you is y minus y1 equals m times x minus x1. Here my y1 is 4, my x1 is 1, and my m is 3. So I'm just going to plug those things in. So we're going to do y minus 4 is 3 times x minus 1. I will distribute, simplify, get everything into slope-intercept form. I don't technically have to, but it is, again, it's a common request, so I'm going to go ahead and do it. Y minus 4 is 3x minus 3. Add 4 to both sides, and I get y equals 3x plus 1. There's my line. Notice that this line is not this line, right? It's a different line, but it's got the same slope, right? I've got this line, this 3 here, and this 3 here. So these lines go in the same direction, but they don't have the same intercept. So they're not the same. So there's what I wanted. And that's kind of all there is to these. We are looking for a point and a slope. Point on the line, slope of the line. That's what we want to find. All right, let's do a really hard one and then call it good, because I think that's all I want to do. So I want to find the equation of the line through, that's though, that's not the word through. Let's try that again. -1, -4. That is perpendicular to I've run out of the room. I need to widen my whiteboard here, which is a nice thing I can do on the computer. Perpendicular to the line through (1, 5) and let's do 2, 8. No, let's do 3, 8. 3, 8. All right. That is kind of a long sentence. So the thing that I like to do is whenever I see something that is describing something visual, like this is describing 2 lines, I want to graph them. I want to draw a picture. Again, I will go back to what I said about, what I said in, what was that? Video 3, I think, about writing, about it's not so much do you have to draw a picture, it's can you draw a picture, right? Do you get to draw a picture? So I get to draw a picture here, so I'm going to. It's just going to be a little sketch. I'm not trying to be super accurate here. 1, 5 is like there, and then 3, 8 is like 3, 8 is like here-ish. All right, so we got that line. That is not the line I want. That is the line that we are trying to be perpendicular to. So the one I want is -1, -4, like down here or something like that. And it's perpendicular to this dotted line here. So the one I want is going to look something like this. All right, so it should have a negative slope apparently. All right, so let's see how that looks. Now, this is the line I'm looking for, the solid one. So I have a point on the line. Great, we're all set there. We're all set on our point. We just need to find the slope of the line that we are looking for. And the only thing I know about it is that it is perpendicular to this dotted line. So if I find the slope of this dotted line, I can then take the negative reciprocal of that to find the slope of the line I want, which is this guy. So let's do that. I'm going to go ahead and use the slope formula. I'm going to call this x1, y1 and x2, y2. And say that my slope for that dotted line is 8 minus 5, right? The difference in the y coordinates divided by the difference in the x coordinates. And by the way, I should point this out. You have to use these in the same order. So because I was doing this one first, the 8 and the 3 both go first. You can switch it around so that you're doing this one first. I could have done 5 and 1 first as well, and it would actually give me the same number. The only thing you can't do is mix the orders, right? So if I do the 8 first, right? If I do 8 minus 5, I can't then do 1 minus 3. It has to be 3 minus 1. So make sure you're using the same point first and the same point second. So when I reduce this, 8 minus 5 is 3, and 3 minus 1 is 2. So the slope of my dotted line is 3/2. That is not the slope that I want, because I want a slope that is perpendicular. So I'm going to flip that over and make it negative. So the slope, I guess I'll do this. I'll say the slope of our line right? I change the sign, and instead of 3/2, we've got 2/3. So -2/3 is the line that we want. Some people will write this like this, M with a little subscript. Looks like an upside down T, but that is actually the mathematical symbol for perpendicular. It's 2 perpendicular lines. And you can write it that way if you want to. That's totally fine. I find that people have trouble, like the more notation I use, the harder things are to understand. If you want to use it, this is called M perp. This symbol right here is pronounced perp, for perpendicular, obviously. But our slope, the one that we want, is -2/3. So I've got a point, -1, -4, not these guys. These are not on our line. These are on the other line. The one we want is on -1, -4. It has a slope of -2/3. So let's go use the point slope formula for that. So make -1, -4. Yeah, okay. So we have -1, -4, minus 4, m equals minus 2/3. That's the thing we want. So we're going to do y minus y1 equals m times x minus x1. And watch your signs, right? When there's negatives in this formula. So you often end up with a bunch of negatives you have to be careful with. So be really careful that you're not losing track of them. This is going to be y plus 4 equals minus 2/3 times x plus 1. I'll go ahead and distribute the minus 2/3 and move the 4 over and get it all into slope-intercept form. Minus 2/3 x minus 2/3. Subtract 4. Now I'm going to go off to the side for a second here. Ooh, that's moving my whole whiteboard. That's not what I wanted to do. So 4, when I subtract this, I'm gonna need to do it in thirds, right? So I need a common denominator of 3 here, and the common denominator here is 1. So 4 is gonna be the same thing as 12 over 3. And so that's the thing I'm gonna be subtracting. So minus 4 minus 12 over 3, and of course those are equal. So I end up with y equals minus 2/3 x minus 14 over 3. That's my line. A little bit messy looking, but that's fine. Sometimes you get practice. And I believe that is all I want to do. Actually, I'm going to do one more that where blindly trying to use the formulas doesn't work. You have to think about this one. So I want to say, find the equation of line. Through 2, 5, perpendicular to y equals 7. So this, we don't have necessarily a good sense of what the slope is here, right? There's no, it's kind of as close to y equals mx plus b form as we're going to get, but it's not exactly that, right? So this is one we have to think about. So I want to do the thing that I've been doing all along, which is to graph things, right? I know I want to be perpendicular to y equals 7. And from the last video on graphing lines, which I'm sure you sat through all 97 minutes of that, right? Y equals 7 is a horizontal line. I know you're thinking y equals, wouldn't that be vertical? No, it's not. This is y equals 7 here. The line we're looking for goes through 2, 5. Right, that's not our line, so 2, 5 would be here-ish, something like that. So I want a line perpendicular to y equals 7 that goes through 2, 5. Well, if y equals 7 is horizontal, the line we're looking for must be vertical. And if I want a vertical line through this point, it looks like this. Add by my red dot right here. Something like that. Close enough. And if you recall, the equation of a vertical line is x equals something. And in this case, x has to be 2, because that's the x coordinate of the point that it's going through. This is the line x equals 2. There is not much calculating to do there. This is a problem that, if you try and use formulas, does not work out very well for a couple of reasons. One, if you recognize that this is a horizontal line, and you remember from last video, horizontal lines have a slope of 0. And so if you try and find the slope of a line perpendicular to that by doing 1 over 0, it doesn't work. or it'd be -1/0, but same deal, it still doesn't work because you're trying to divide by 0. And so you can't use a formula to find this. You have to just think. Like, that's the only way to do it. So whenever you get a real stumper, let me suggest that you not try to fall back on formulas or remember other things that you've done that way, but instead graph stuff and think about the problem. That's almost always the best way to do it. Don't go looking for some formula or casting about for some formula to use. Instead, try to think about what the question's asking. See if you can graph and figure it out. And a lot of the time you'll be able to, right? Like, if you just tried to use the formula, you would get stuck on this. I know that. Okay, I don't know if you would get stuck on this. Many of my students would get stuck on this. I know because I used to ask a problem like this on previous homeworks. And people always had trouble with it, always had tons of trouble with it, even though it's actually a lot easier than something like this, right? This one you can use a formula for. You can use a couple of formulas for, and it's, longer, trickier, more fractions, more negatives than usual, but it follows essentially the same formula, and so you can use the same strategy. And when you try to use that strategy here, it just fails totally. But if you think about this one, it's super simple, right? And so let me encourage you, if you are getting stuck on something, to stop, back up to the beginning of the problem and think to yourself, can I do this another way? Can I draw a picture and see what's going on here? That's really the best way to attack math problems. And in fact, if you learn nothing else from my class, but do learn that, I will probably not pass you because you have to learn some math. But that is the thing that I would be happiest to have you learn, is back up to the beginning, go back to like first principles, whatever the question is asking. Let's just graph things and kind of fool around with it until we see something, right? That actually is the best way to solve math problems. Looking for formulas isn't, but having a formula that you know for a certain type is great. So there you go. That's really all I wanted to say about finding the equations of lines. Let me back up to the beginning here and re-summarize. So the basic idea is this. You're going to use this formula, and you need those two pieces of information. You need a point, and you need the slope of the line. That's all you need. Every time you're asked to find the equation of a line, that is what you were looking for. You were looking for any point on the line and the slope of the line. When you have it, you just plug it in and then simplify, and that's it, right? Sometimes that gets a little bit messy. Sometimes you have to figure out the slope using slope formula. Here, I used the slope formula, although I didn't call it that at the time. And we only learned it over where's here. All right, there's my slope formula. Do remember this formula, but more importantly, remember what it's finding rise and run. And if you forget the formula, you can always just graph the 2 points and count the number of spaces. That works totally fine. And then we learned about parallel and perpendicular. Parallel, same slope. Perpendicular, opposite reciprocal slopes. Parallel question, not particularly hard, right? We find the slope of the line that we are parallel to, and then we plug everything into the point slope formula and we're done. Perpendicular, harder. You find the slope of the line that we are perpendicular to, then flip that over and make it negative, then plug that all into the point slope formula and simplify. And again, sometimes you get fractions. And then the tricky kind, the kind where the lines that are parallel or perpendicular do not have a nice slope, right? This one kind of does have a nice slope. It has a nice slope. The slope of this line is 0. The slope of this red line, by the way, is undefined. It's effectively infinity, but it's better to describe it as undefined because it is 1/0, right? It's what you get when you divide by 0. So if it says undefined slope, you're not going to be able to find it from a formula. You have to just think about what this question is asking, and then it's actually not very hard. And that, I think, is the last thing I wanted to talk about with finding the equation of lines. So I will go ahead and stop the video right here, and I will see you guys in the next one.